Hello everyone and welcome to my new video. And what is this video about? Well, as you can probably guess, it's about Max 8.3.2, a new update that came this week. Not a considerably large update, but has some interesting things in there which I'm going to talk about, which I've been meaning to talk about for a while, but I decided to wait because I heard on the grapevine that some things were coming, and indeed they did. So Max 8.3 has been out for most of this year, and there's a huge load of stuff in there that I've been meaning to talk about, but I haven't yet because I wanted to understand it better rather than just going in like a dumbass. However, that's exactly what I'm going to do today. So everything I just said was nonsense. What we're going to do is we're going to look at jit.gl.pbr. What is jit.gl.pbr? PBR stands for physically based rendering. I'm no 3D artist, so some of this stuff is a little bit alien to me. I'm going to teach myself this. Jit.gl.pbr is something of a successor to jit.gl.material. Basically, it's ways that you can use assets from the real world, or indeed any world, and just make things look more realistic, or not, make them look unreal. You can use it to make things look more textured. I don't know which one I prefer. I'll keep the material over there, but jit.gl.pbr is new in 8.3, and in 8.3.2 it can now receive textures as inputs rather than just matrices, which is good because that means we can run on the GPU and get slightly better performance. Anyway, let's open the help file and have a look. So jit.gl.pbr, generate physically based rendering materials for 3D objects, produce shaders for physically based rendering PBR that automatically adapt to texture inputs and the number of active light. So let's turn this on. Okay, we got a donut. So we've got some things down here: albedo, normal, roughness, metallic, occlusion, height, emission, words people, and we've also got environment. So basically, these are maps. Normals for lighting, roughness, metallic. You can get all of these things from the internet and and other places. I went out earlier with my iPhone to go and take some photographs to use in this video to make it more exciting. However, some of those were a failure. I wanted to take a HDRI scan of this heavily graffitied sort of subway pass near where I live, and the app failed. As a compromise, I came back and took a 3D scan of this room, which I am sitting in right now, which I have somewhere on my desktop. So I'm going to load that into the environment map. Yep, this is it. So this is what it looks like. That's my room taken as an HDRI. It's very grungy. And I'm going to drop that into the environment map. It's going to load. Okay, so that has now... oh, hang on. There we go. So... okay, so that has now loaded into... we can't see it. So let's take this handle here and connect it to our skybox so that we can just have a look around. Yeah, that's my room. This is my room where I am sitting right now. I'm currently sat in that chair there. So we've made an environment map, and the jit.gl.pbr is going to shade this donut in ways that it will respond to the environment. This is interesting. So let's just sort of make it get an angle like that. There's my push. There's my Ableton push down there. So we've got some things here. Metalness. Let's turn up the metalness. All right. So we can see that it's starting to look a little bit more metallic. Let's pull the roughness down. Roughness. Look at that. Woo! Look at that. Okay, let's connect the handle back to the donut. We can move the donut around so you can see how it's reflecting. It's reflecting the environment on the object. Pretty cool. So we can do this. What have we got here? We can turn off the gamma correction, and that's just sort of a little bit more reflective. This is exciting. Look at that. There's my room on a donut. Happy days are here. So, yeah. So we've got some different things we can play with here. The roughness will make it look more rough. So you can see, we can go quite extreme with the metalness. You can really crank. Oh, that's a little bit too much. So anyway, so this is basically what we can do with jit.gl.pbr. We've also got some things here where we can specify a normal map, a roughness map, blah, blah, blah. I went out and took a photograph of some leaves because it's autumn using an app called Live Normal, which enabled me to take a photograph and convert it to, you know, like a height map, which I've got somewhere here. It rather irritatingly didn't name the images according to what type of image they are, but I know for a fact that that is the normal. So I'm going to drop that into the normal here. And so you can see, look at that. So that's actually now been shaded according to the normal map of the photograph of the leaves that I took. It looks pretty cool. This I'm fairly certain is the height map. So I'm going to drop that into the height map. And I think in order for that to work in jit.gl.pbr, we have to enable parallax. So I'm going to hack the help file and enable parallax. And there's the height map. Look at that. Already it looks kind of cool. Leafy donut in my room. Okay, so we can also play around with the height scale and really, really crank that. Interesting. Okay, let's try, I don't know what any, so that's basically the leaves. Let's just drop that into the albedo and see what we get. Okay, this is the, that's white. This I think is the, I don't know. Let's just drop it into the metallic and see what happens. All right, okay. So you can see how it's looking a little bit leafy, but it still looks like it's made of metal. It's very exciting, very weird. And I'm interested and I'm going to play with this. But what if you don't have any of these things? What if you don't have height maps, bump maps, normal maps? What if you don't have a 3D scanner on your phone and you can't take 3D scans of environments, or, you know, what are you going to do? Well, we can actually do it all kind of procedurally as well. And that was really what I wanted to talk about. So let's close the jit.gl.pbr help file, go back to our main patch, and let's do some stuff. So first of all, let's get rid of that. Let's make a, I need to get cozy. I need to get cozy. Turn on the grid, snap to grid. Okay, so let's make a jit.world at floating 1 at enable 1 at erase color 0001. Okay, there's our world. So let's take our PBR. Let's keep our material here for now. Let's make a grid shape. jit.gl.gridshape at shape sphere. Sphere at dim 100 by 100 at smooth shading 1. Okay. Let's make a jit.gl.handle, jit.gl.handle, connect that to the world. Let's make a reset message. So we can reset that and then we can have a look around our sphere. So straight away, if we connect the jit.gl.pbr to the grid shape, it's already going to start shading it. But we haven't really specified anything interesting about that. So we're going to do that now. And I'm going to do that with jit.gl.bfg, which stands for basic function graph, I think. Let's have a look at the help file. Basic procedural basis function texture. It makes cool things. So let's have a look at what that's doing straight off with a jit.p window. Okay, so I'm going to use this jit.gl.bfg to shade my grid shape via the jit.gl.pbr. So pretty much straight away, we can just start messing around with this. I'm going to load up a few attributes here, the zoom, the basis, and the time. Where is the time? Okay, so we've got a couple of things here we can play with. The basis is the type of function. So we've got Perlin, cell, which I like very much, and then all these sort of fractal ones. And as we increase the zoom, we kind of get more detail. And then if we adjust the time, we can kind of animate that a little bit. So I'm going to use all of these things to procedurally animate my shading, I guess. So let's just connect. Let's connect. So let's connect that to the albedo. Already it's doing something there. Let's connect this to, not the normal, the roughness. Let's connect it to the metallic. Let's connect it to the ambient occlusion. Who cares? Let's just do it. It's just all for fun. The height, yeah, it's connected to the height. And let's connect the emission. I don't think so. And not the environment. Okay, so already we are shading our sphere using our basic function graph generator thingy. Let's make this a little bit bigger so we can see it. Let's make it white. Or indeed yellow. No, I want white. Thank you. Okay. Or maybe teal. Let's go with teal. So as I sort of adjust some things here with the BFG, it obviously makes an impact on the shading of the object. Okay. There is some light here, although I didn't specify any light. So I'm just going to create a light, jit.gl.light at look at, oh, all right, position 002 at look at 000. Ah, cool. No, let's try 5. No, I'm not very good with the light. Let's try this 0, 0. Maybe I need to specify. Let's specify a point at type point light. Okay. Okay. All right, so we're lighting it now in front. We are kind of lighting it from the front. It's not the best. That's a little bit better. Okay, so now we can sort of, we're lighting it, and then if we move our light, then you can see the light's moving around the surface. Yeah, okay. So let's have a look at the height map. We're using our BFG here to specify the height via this input, but we need to enable that with the parallax. So let's enable parallax, and now we have some height, and then we can go to our height scale and really overdrive that height. Yeah, ugh, look at that. It's creepy. That's creepy and weird. Okay, so let's animate this. We can animate this with jit.time. So jit.time is a bunch of objects that will make numbers, I believe, at the frame rate of the rendering scene. So let's do let's do jit.time, which is basically just going to count forever. That's just counting. I'm going to use that to animate the time attribute of my function. So I'm going to say prepend time, connect that to the prepend time, and then connect that to the BFG. And now it's animating. It looks kind of ugly. Let's look at some different functions. That's cool. So it's kind of weird. It looks a bit weird on a sphere. Let's try a cube instead. Let's change it to a cube. Okay. We zoom in a little bit here. So that looks like what we might expect. The difference between this and jit.gl.material, I believe, is that the height map doesn't actually do anything to the vertices. It's all kind of an illusion. I don't know much about this stuff, so if anyone out there wants to help me out. But like, if we actually look at this from the side, you can see it's flat. It looks like it's not, but it is. So this is different to jit.gl.material that will actually displace these vertices. Anyway, interesting. So this is fun. Let's try a different function again. Let's bring the zoom down a bit. Yeah, look at that. So let's play around with some of the other things on the PBR. Let's go with the metalness, and let's go with the roughness. Let's increase the metalness to like 1. Let's bring the roughness down. Okay, let's change the color to something a bit brighter. Let's go for white. Do I need to make the grid shape white as well? Let's see. no difference was made. Okay, let's bring the roughness back up. So you can see we can get some interesting stuff here. Whoa. Yeah, let's change it back to a sphere. Let's animate this some more. Yeah. Okay. There's going to be moments where I'm probably going to say nothing because I'm just intrigued by this. That's very dark. Let's go back to the cell. Okay, that's a little bit more interesting. Okay, so it looks pretty good and it's running nicely on my M1. No fan noise yet, I don't think. No fan. Okay, so let's do some more strange animations. Let's animate the height scale. Let's make a jit.time.perlin, which will do random values between 0 and 1, but we can actually increase the scale of that from something like, let's say the scale is 10, and let's give it a speed of 0.01. And then that's just going to, let's maybe go a bit faster. 0.1. Yeah. Let's increase the zoom. So we're kind of modulating the amount of height that we're applying. This is kind of fun. I don't like that light at all. I'm just going to trash the light. Okay, goodbye light. It was fun, but wasn't working. So, okay, let's increase that scale of that height. Maybe even more. Let's go for 50. Not to 50. Okay, so there we go. So that's looking kind of weird. Let's do something with the zoom as well. Let's heavily modulate that zoom. Take a copy of that jit.time.perlin. Let's maybe say go to 20. Oh, that's a bit fast. Okay, let's go a bit slower. Yeah. Weird. Okay. Let's have a look at some different colors. Eggplant. Okay. All right. So what about maybe procedurally creating an environment map? So we're going to need a couple of things. We're going to need jit.gl.pbr, and which we will use to generate our environment, which we will connect to the environment input of our jit.gl.pbr, and indeed to our skybox, jit.gl.skybox, which will create a skybox for our world, for our jit.world. So I'm going to basically just generate this cube map with a jit.noise. Jit.noise. I'm going to say 3 planes, float 32 at 10 by 10. So when I bang that, we're just going to get a little matrix of random colors like that. But when I put that into my cube map, first of all, I need to, let me check the help file. Yeah, I need the pre-penned panorama matrix message. So I'm going to copy that from the help file, paste that in there, and then I'm going to plug my noise into this message and connect that to my map, cube map. I think I might need to bang it after I've done that. Let's see if this works. Okay, I've banged the noise, I've populated the cube map, and now I've populated my skybox with this, but not my environment. So let's take the output of the jit.gl.cube map and connect it to the environment of our jit.gl.pbr and bang it again and again. So now, yeah, our object is reflecting. Well, it's not reflecting. We need to turn that on. So let's go to, reflection is already on. So it might not be really obvious, but the object is now reflecting to our environment map, which I've generated using jit.noise. So I can generate a new one. And indeed, the colors will, you can see how it's kind of reflecting the colors generated by the environment. maybe I might do, let's do a trigger BB, bang the noise, bang the cube map, so that we can do that in one bang. Okay, so you can kind of see there that it's, yeah, it's sort of responding to stuff that's going on in the environment. Let's increase the metalness some more. Ooh, look at that. Very weird. Let's put the roughness to 0. So yeah, you can definitely see a lot more. It's reflecting the reds and the greens and the blues and all that sort of stuff. Let's try a different function. Let's have a look at fractal hetero. Woo! Yeah. Fun stuff. Let's have a look at distorted. Yeah. So there are all of these different things that we can play with and make these animations and stuff. Let's have another look at it on a cube. Pretty cool. Let's try noise purling. No, fractal multi-rigid. Yeah, let's pull that metalness down a little bit, maybe to 2. Increase that roughness a bit there. So you can start to, let's put that to 2 maybe, so you can kind of see some of those details coming in now with the lighting and the reflection from the environment. Very nice. Just going to slow that zoom speed down a little bit. Maybe the height map thing as well. Let's slow that down a bit. And indeed time, let's slow the prepend time down a little bit at speed 0.1. There we go. So we can just have a little bit more time to explore what's going on here. Ugh. So if we increase the dimensions, I think, of our sphere, we might get even more detail. Let's push this M1. Let's see what it will do. 300 by 300 dimensions. So yeah, we're definitely getting some more detail there. Let's go a bit bigger. Yeah, fun. Okay. Let's animate this a little bit more. I've got a couple of snippets that I made. I've got one for to move my camera. Let's see if this is a snippet. Snippets are really cool. You can make a little patch and save it as a snippet and paste it in whenever you want. So I've done one to move the camera around, which I'll talk you through. Basically, it's there's a camera which is looking at 0 and the look is locked. And then I'm just modulating the position with a load of jit.time.purlins here, and then a top purlin to modulate the speed of those purlins. And then what we get is this sort of, we can kind of move around the object like that. It's sort of, looks kind of fun. Let's generate a new environment. Let's generate a new environment every second. Metro 100. Let's turn that on. And just generate a new environment every second, just for fun. Okay. Nice. All right, let's do a little bit of post-processing on the world. Let's get rid of some of this stuff. Let's get rid of these bangs. Don't really need those anymore. Okay, so let's just do a little bit of finishing off here. Lots to explore, too much to explore. Just wanted to jump in and have a bit of a fiddle around and see what we've got. So let's look at some post-processing here. Let's have a look at, it's already quite messy. Let's have a look at jit.gl.pass at effects name bloom_HQ. And let's have a look for the threshold attribute, and let's pull that threshold down, right down to beneath 0. Let's maybe say 0.9. So that's just adding a little bit of bloom. No roughness. Whoa! Ooh, look at it. Oh, it looks weird. It's fun. Okay. All right, and then let's maybe do. I maybe want to increase the scale of these a little bit. So maybe I'll do like prepend scale, and I'll connect to each of these, and then I can just make it maybe go a little bit further away. We don't need a float. Let's do it with an integer. We can maybe make it go a little bit further away from the, yeah. All right. Maybe we could make it go a bit faster. Let's maybe say scale 0.1. Okay, now it's going a bit faster. Yeah, cool. So now I'm going to add another pass. I'm going to do jit.gl.pass at fx name motion blur. I think it's all one word. It's going to start strobing. That's bad. Okay, we need to connect to the middle outlet of the top pass to the second one. Now we've got a bit of motion blur. I think. Did I spell that right? Did I use the right? Yes, I did. So now we can adjust the velocity scale of that. Let's set it to 20. And then when the camera moves really fast, it's going to create a bit of motion blur like that. Lovely. Let's go a bit bigger. Ooh. So, I mean, you know, it's not the most inspiring thing in the world, but it's a starting point to explore what you can do with jit.gl.pbr in terms of shading objects in a 3D space. And the fact that we're doing it kind of procedurally means that, you know, we can do it kind of with anything. I mean, we could use a webcam, we could use a video file, we could use some matrix data that we've acquired from analyzing audio. We don't necessarily have to use bump maps of leaves, although if you're into that sort of stuff, there are ways to do that. And of course, you can get all kinds of things off the internet. Let's have a look at let's have a look at a cube. Ooh, yeah. I'm impressed with the M1 handling this. Looking good. Let's try different function. Let's try cell. I like cell. So yeah, there's obviously it looks very computery, but it's just kind of satisfying, you know. Yeah, we just made a little animation, and it has some depth to it, and some dreadful color schemes. Disco Cube. All right, I think that'll do. I'm going to go and put this patch on my Patreon now, and where you can go and support me and download that and play around with this, or just follow along at home and try it yourself. It's jit.gl.pbr. Interesting times. Now taking texture inputs, which is really good because we can do all the processing, all the shading on the GPU, but not exclusively. You can use matrices as well. Look at that. Look what it's doing. It's cool. All right. So that was a little introduction to jit.gl.pbr in Max 8.3 with a load of other things as well to make interesting animations and light them and give them materials and stuff like this. I can't really stop watching it. Obviously, I could definitely do loads better. All right, that's it. Thanks, everyone. See you next time. Bye.